starting with the biggest question probably on your mind, which is what even is programming?
Well, the dictionary defines it as the process of preparing an instructional program for a device. But that's a really confusing definition. So, in layman's terms, what exactly does that mean? Essentially, it is attempting to get a computer to complete a specific task without making mistakes. Imagine this, for example. You want your less than intelligent friend to build a Lego set, except he has lost the instructions and can only build based on your commands. Remember though, your friend is far from competent, and so if they are not given very specific instructions on how to build the set, there are many mistakes that they could make. If he thinks like a computer, then if there is even one piece that you have not told him specifically where to place and how to place it, the entire Lego set will be ruined, and he will be left to suffer a complete mental breakdown, causing the whole goal of the project to be corrupted. Giving instructions to your friend is very similar to how programmers code. Instead of a less than intelligent friend, you have a less than intelligent computer. And instead of instructions on how to build a Lego set, we are feeding it information on how to complete a program, like a game or a web application. An important thing to note is that computers are actually very dumb. We built them up to be this super sophisticated piece of technology, when in actuality, a computer's main functionality comes from how we manipulate it to serve our needs. Now, programming isn't as simple as giving your friend instructions, since in a programmer's case, the computer doesn't speak the same language as you. The computer only understands machine code, which is a numerical language known as binary, that is designed so that the computer can quickly read it and carry out its instructions. Every instruction fed to the computer is converted into a string of ones and zeros, and then interpreted by the computer to carry out a task. Going back to the Lego example, this process would be like if he was not only less than intelligent, but to make matters worse, he could not understand English and only speaks in Mandarin Chinese. In order to speak with him, you have to convert the instructions that you understand in English into the language that your friend understands. This process is essentially what you must do for your computer in order to make it understand the instructions that you give it. The big difference between the two examples, however, is that it is very difficult for people to understand machine code in binary. Directly translating what you want the computer to do into machine code is extremely difficult, in fact almost impossible, and would take a very long time to do it if you could. Each program is composed of millions upon millions of those ones and zeros, so how, exactly, are we supposed to translate our instructions into machine code? This is where programming languages come into play. Programming languages are fundamentally a middleman for translating a program into machine code. These languages are much easier for humans to learn than machine code, and thus are very useful for programmers. Going back to our Lego example, a programming language would sort of be like an interpreter that's able to take the instructions you give them in English and translate them into instructions your non-English speaking friend can understand. This makes programming languages extremely useful and the backbone of any good program. Think of programming languages as not English and not machine code, but somewhere in the middle. There are many different programming languages out there that each have their own unique uses. Languages such as Python and Java act as general-purpose languages that can perform a variety of computational tasks, while Robot-C or HTML or CSS are languages designed for more specific purposes, such as moving a robot or constructing a website. Languages can also vary in how powerful they are. For instance, JavaScript is a scripting language that is designed for smaller tasks, while Java or Python can carry out much more computationally taxing processes. We can measure a programming language's power, or level, by how similar it is to machine code, the series of zeros and ones we talked about earlier. Low-level programming languages, such as assembly or C, are closer to binary than a high-level programming language, such as Java or Python. The basic idea is that the lower the level of your programming language, the more your code will resemble what the machine can interpret as instructions. Aside from the different purposes that each language fulfills, choosing a language typically comes down to a matter of preference, as there are usually many languages that can accomplish similar tasks. Try different languages and decide which one's rules, interface, and level of simplification you like best.